Okay.
Okay,
Do we get this up in all times?
yes,
Okay.
all things. Welcome everybody to this month's Film Meetup. I'm so glad you can all make it. I'm Mariah, for any of you who have not met me before. Be a pretty familiar face for anybody who's come to a meetup in the last, I don't know how many months I've been in charge. 6 months.
Feels like it.
Forever. I just want to remind everybody that Forge Utah has a Slack. Forge Utah is the nonprofit group that sponsors all of the meetups that we host here at Weave and a couple more. We have a Slack to be able to connect with everybody here and the people that attend the other meetups. We've got some pretty great channels and other things offered there. Also reminders and I don't know, we post a lot of things about new technologies. I post about machine learning a lot. We get Golang questions answered, all that great stuff. So remember to join us at Slack, follow us on Twitter, where I tend to post all of the meetup stuff. I didn't post today's meetup. Dang it, I forgot my spam of the day.
I'm so sad.
Oh my goodness, how can people live without my spam? Just real quick, I wanted to open up the floor if anybody has any jobs at their company that they'd like to announce. Feel free.
Well, Weave's always hiring. We have a few open recs for Go developers, so I don't think that's a surprise to anyone here.
If you want to work at Weave, talk to Garrett.
MX is hiring. We're just about a couple blocks that way, looking for programmers that know Go and want to work in Go and Ruby.
Ruby?
Or that know Ruby and want to learn Go. Either way.
All of the above. Anybody else? Just MX and Weave? Oh, Garrett said Weave. Do you want to say Weave again, John?
My team's hiring. Weave.
If you want to work at Weave, talk to John.
No. Did not say that.
Okay, talk to just Garrett. Anybody else? No? Cool. We do have a jobs channel that people have posted on occasionally. So feel free to check that out too, because everybody should join Slack and get my spams on Slack. So tonight we have Garrett speaking. He works here at Weave. He does data and makes sure that we don't violate any of the 20 billion laws that exist in the entire world. He studies case law on the side in his free time, which is only between 2 a.m. and 4 a.m. to make sure we don't violate any of these laws. So, make sure to ask him all the hard questions. But I'll let you introduce yourself, Garrett, and the floor is all yours. Let's give him a...
Let's see if the technology fails me today. So.
You should just airplay it.
I will, but somehow, some way, the technology will fail me. So
Just don't bring your Bluetooth mouse down.
that's right. So one of the first stories that when I was first starting here at Weave, for any of you that don't know Clint, he's our CTO, and he was giving a presentation. And let's see if I can find. Of course, the training is not showing up on there.
It's second from the bottom, isn't it?
So here we start with the technology films.
So then you go to system preferences, Bluetooth, yeah. Actually, if you just do command space AirPlay, it pulls up as the first option.
Yeah, I was just connected to this, and now it's not there.
It's connected, I'm over AirPlay.
It's connected, and I'll see if it shows up. So the first meetup I attended, Clint's giving a presentation, and he decides to be able to see what's behind him here. And so he turns the podium, and as he turns the podium, the blade breaks off, and the podium falls over. He has a cup down here, and it starts to pour everywhere. And he's like, this is happening, as the entire podium is falling over. So he then takes a seat right there, messing with all these cables, and myself and another engineer help him clean up the mess. And what I realized at the point in time I started cleaning off the Bluetooth keyboard was that the Bluetooth keyboard was attached to his machine. So the entire rest of the presentation, as he was attempting to write Go code, I was randomly hitting letters on that keyboard. He could not figure out what was going on until the very end when one of the other engineers from Weave went and told him what was happening. So I have a very much, I try not to take life serious at all. It is just too short to do so. And so,
Did you find it?
no, but I literally was just connected. This is, okay, so Zoom. We'll try this in another way.
Travis, you missed the already hiring. Is
Who's hiring?
664
664 747
914.
914. Just three? So hopefully here I end up in double audio. This works better. So with all that being said, what I did to Clint, and he eventually found out, every time I'm giving a presentation now, and if I have my Slack open, he sends me messages that just sit there and pop up the entire time. So I've gotten really good at sharing just the specific screen that I need, so as to not end up facing the wrath of so let's go ahead and see if this works if I can present. The only thing I don't like about using Zoom is I can't see my notes. So I'm going to wing this. About me here. I have been developing for about 20 years through, yeah,
Okay, just making sure you're all ready.
thank
I'll
you.
quit talking now.
About 20 years for any of you that are this old, my original job that I had was converting Fortran code to VB3. So I've been around a little while. Joined Weave about 18 months ago, mostly to help them with some of their data needs and some of their security needs. I spent the last 18 months learning Go and Kubernetes. Previous to that, I was director of security at MX, new virtual machines and deployed data centers all over the world. But Go and Kubernetes provides a completely different attack surface and a completely different process in which you can attack systems. So tonight, a little bit about where is security. And we'll go over security and then Docker and Kubernetes. That's what a lot of people that use Go end up using those in combination to deploy their app. And so where does security live? Well, it's in your code. It's in your container. If you're using open source, it happens to be in the other guy's code too as well. So that's, if you, in the past, a lot of times people viewed security as just their code, just what they're writing. But as DevOps and as Kubernetes and those things have become easier and more accessible to engineers, the scope of what security and who owns it is changing. And so these are areas that, if not currently, will in the future be important to all engineers, I believe. Who is security? You yourself and the other team. Right now, there's a lot in the industry that toss it over the fence and say it's just security's problem. That, however, has not worked and has led to some very bad behaviors and very bad outcomes. And so I believe that as engineers, who here has a current like security director that they absolutely love working with? Who has a security director they hate working with? Come on, somebody's had a security director. I've worked with lots of security directors, And most of them I wanted to throat punch, like on a daily basis, because it felt like they always threw out things that were unnecessary. And so as an engineer, I became super interested in security, mostly to understand the reason why they were trying to get me to do something, as well as to be able to kind of control my own fate as to what security should look like from an engineer's perspective. So here comes Go. Let's talk about Go. Go is an amazing language. It compiles, which is so much better than most other languages like Ruby and Node. So it makes it so that the code can't be changed on the server. So it eliminates a massive attack vector that you don't get with other languages. Other languages, if you're running Ruby, you can go on that server, change the code, and it comes right back up. Go, compiled artifacts, compiled code. The ability to change that executable exists, especially with some of the stuff I'm going to show tonight. It exists to alter it, but it's much, much more complex. And Google specifically built Go with security in mind. So over the last 18 months, I love Go. So many great things about it. Now
The middle one's a lie, right?
What's that?
Like you're gonna tell us that middle one's a lie. That's gonna be the next slide, right?
No, that's the philosophy, right? If it compiles, there's no errors, we're good to go. But that's not the case. It's great. It does provide you a little level of saying, oh, okay, this might work, but it is a lie. So, have any of you ever done that where you're like, it compiles and then it just actually doesn't do anything in production? It's fantastic.
Wow, ship it.
File and ship it. Can't say I've ever been there, done that. Yeah. So Go, great. The ecosystem around Go and what you do around Go is currently leaving much to be desired. So we'll get into that. Why security? Mostly to protect your customers, protect yourself. And tonight we'll talk a little bit about what's called shifting security to the left. For far too long, security's kind of been dictated to engineers, dictated to the organization. It hasn't worked. It hasn't worked at all. Like it's failed miserably due to the breaches over and over again. Shifting it to the left, including it in conversations, prior development cycles, as well as getting engineers on board and to be thinking about data. Thinking about data and how they will use that data, how someone else might use that data. It all comes down to the data. Most of security is around data. Now, because it's not compliance, put that in there. A lot of times people confuse security and compliance. They're not the same thing. I mostly dislike compliance. The aspect of security on your home is a deadbolt. The aspect of compliance in your home is the little power covers that have literally never done anything for you. But they're a part of the laws, and so you have to have them on your house. Whereas a deadbolt and locking your doors has the aspect of providing some physical security. So the difference between security and compliance is like, crap, I have to do it. Security should be about the protections that you're offering your company, yourself, and your customers. Shifting security to the left. So, I want to talk about this a lot. And without my notes, I may have jumped ahead a slide, but I believe in educating engineers and continually educating on security and the technologies they're using. There's been an evolution from having physical boxes to VMs and now Kubernetes and containing running environments. And each generation of things starts with the security story being mostly terrible. I remember a few years back, they were showing how on Azure they could breach the Hyper-V through the host boxes and then gain access to every VM. That's become less and less. And this year was mostly terrifying around what people were able to do in Kubernetes.
You're talking about a black hat, right?
Yes,
Okay.
Blackhat and Defcon.
He's wearing a black hat shirt, if you can't tell.
Yes. Have any of you guys here been to Blackhat or Defcon? Did you guys go this year?
No.
No, it was phenomenal. So when I talk later on about Sky Talks, you'll know what I'm talking about. But educating engineers. I also believe that the security industry is going to have to move away from less fear factor. Like every time you talk to a security person, it's all about fear and the terrible things that can happen. For the language of like risk. Business is risk, and educating people to know what the risks they have, and then allowing business owners, business individuals deciding whether that risk is acceptable. It's not about dictating to them, you have to do it this way. You can choose to do it any way you want. These are the risks. And guess what? When you're first starting up, security goes out the window because you're trying to make money. If you don't make money, you're not alive. But as you evolve, and as you grow bigger, it's about making sure you have your risk profile reduced. Because there are people, online hacker databases that essentially scan all the internet, record what they find, and then sell that information, any vulnerabilities or anything they found, to other people. That's continually going on throughout the world, that there's scans and records of what they find being published and bought. So going to get into a little bit of detail as to some of the security pieces, since it was about secure coding. OS TopTen. These are some of the best practices for security. Again, depends on the state of your company, as well as your inkling to understand the things that you're working with. The primary one being injection. We'll go over a few of those tonight to show how injection gets used. Let's talk about broken authentication, because I don't think I have it on any other slide. So I won't name the company this happened at, but everyone here has heard of OAuth, right? It's amazing. OAuth, you can use that. It's secure. Well, what happens if you forget to validate that certificate? Validation is huge on injection and broken authentication. If you forget to validate an OAuth certificate, anyone can put their information in there and go in as themselves, or go in as you. I can go in as anyone I want if I don't validate that token. That may have happened somewhere recently. Sensitive data exposure is a big one. I'm sure you guys have all heard of Capital One and Equifax and all of those that have exposed data. Equifax is a fascinating story. They fired 2/3 of their security teams and then had a breach. And the only way they actually were able to identify who had been accessed was because their previous security team had set up monitoring that the new team didn't know about. The FBI used to patch it together. So that's slightly terrifying. Broken access control, XML, external entities. Who's using XML anymore? I don't worry about that one. It's the ability to cause buffer overflows by diving too deep into a complex XML document, and you can then inject additional code into those XML documents that have unexpected consequences, buffer overflows that allow then vulnerabilities to be injected. So broken access control, again, that's just something that as operationally access control is not being checked, it's a repeated offender for vulnerabilities and data exposures. The next 5, security misconfigurations, cross-site scripting, insecure deserialization, using components with known vulnerabilities, and insufficient logging and monitoring. That's security misconfiguration. Everyone hear about Capital One? 100 million customers' data leaked because they had a certificate essentially sitting in a AWS bucket that was retrieved by an AWS employee and had access to everything in their infrastructure. So it's chalked up to a misconfiguration because it should have been a deny, and it wasn't. Only affected 100 million people. So lots of details there. Using components with known vulnerabilities. We'll get into this a little bit later. But with open source, I love open source. The idea behind open source has always been that the more eyes you have on it, the more secure it's going to be. And to some extent, that is the case. However, we're mostly terrible at updating our dependencies. And so unless you're watching for it and know what you're using, you're going to miss the problem. And then someone's going to come by. And that's the comment early on of the other guy's code. You got to be aware of what you're using. And if it's the other guy's code, watch for CVEs that will be coming out around that. Let's see. Okay, so we're going to go into SQL injection. This is pretty much, everyone should know this. If you're new to coding, watch for SQL injection. SQL injection, essentially, this is off of XKCD. I feel like it's skipped the slide, so I'm going to go back one. I did. There we go. It skipped the slide. I was like, wait a minute. When it talks about injection, the primary things on injection are validation and sanitization. And what that means is you're checking all of your parameters on the server, you're checking the width of them, you're checking, and then in the white space, you are checking that if you're expecting a text that you're not getting HTML, if you're expecting HTML, that you're getting HTML. All of those pieces come into play on what then you are either allowing to be exposed to, and we'll go over some things that, at DEFCON that literally one character content length in your header exposes you to problems. And so validation. This, when they talk about injection for all OWASP, TopTen, they have 13 points of validation. And you say, and it's pretty common stuff. Clean up your white space. Clean up, make sure that if you're only expecting 50 characters, that you're constraining it down to 50 characters. And if any of the validations fail, reject the input. Say, sorry, this can't go through. So, let's see if it doesn't matter. Is thinking about it. Oh, come on. It keeps jumping ahead 2 slides. So SQL injection. Early on in my career, this wasn't a thing. And then, literally in like 3 weeks of time, I got calls from 3 different companies that I had consulted with in the past about like their user tables being wiped out. And at the time, people didn't know what it was that was causing it. Okay? It was SQL injection when it first started coming out. They, in the names, you know, one of my top favorite things to do, and we'll get to this a little bit later, but is this and Crosssite scripting are so easy to combine and cause problems. But people were using like password fields to essentially SQL inject a delete command. So how do you overcome SQL injection? 99% of all SQL injection can be overcome by using parameterized queries. Just use parameterized queries and you will not have a body drop table moment. Here's how you use SQL. This is how you prevent injection. These are parameterized. These are the different variables that you have. And every time I talk about this, there's always some like, but I have this thing that has 50 columns of data that's comma separated. How do I do that? Well, you can create 50 variables and parse that out. There are ways around it. Always use parameterized queries. Parameterized queries do not solve all your problems, however. I wish that were the case. There are still exceptions. One of those exceptions came up during DEFCON. They're using SQLite. They have compromised because of how SQLite works and the protocols it uses. They've compromised Android machines, Android phones, without using SQL injection. So doesn't solve every problem. The other caveat of parameterized queries is it doesn't save you from the next problem. Let's see. Oh, I don't know what slide it's on now. Click the button. Oh. Okay. I'm skipping something here. Oh, I messed up my slide deck. So let me talk about this. So cross-site scripting is going to appear like 5 slides later, but I'm going to go into it right now. So one of my favorite things to do at a company when I first get there is go into your profile name and you put script, alert, my name, and script. If it takes it, then you start hearing things in your QA and people going, why is your name popping up here? Why am I getting this box on my screen? Guess what? That piece of code is now saved in the database. It's not a SQL injection problem. It just became a cross-site scripting problem, where I could literally tell this software to load any script I wanted and to execute anything I wanted, because that piece of text was not validated for whether or not it has HTML tags. First names, unless there's something really wrong, should not have HTML tags in them. You know? So there's techniques there that you can use to prevent cross-site scripting. And so I'm going to jump into a demonstration of that. This was the easiest thing I could quickly do. Now, you want to know a funny thing? Is all the new Google Chromes have cross-site scripting currently. If you try to do cross-site scripting on accident, it pops up and it's like, hey, I recognized what you did, and we'll disable it. So that's beautiful. However, it's not going to protect you, it doesn't protect you from a value loaded from a database that then has that. It's like, oh, okay, look, that's correct. So let me try to share my next screen here, and hopefully this works. Now I just have to find where Zoom went. Let's see here. Stop sharing for a moment. Share again. And so Firefox. So this is a super simple, and I'll show you the code. And this is where your Go code, and depending on how you put it together and construct it, can cause you to have the cross-site scripting done to you. Very simple code. I'll run through the demonstration, and then I'll show you the code. So literally, I am reading off the last parameter called yippee, and so we'll go yippee2. Oh, I'll clear it all. That's not what I want to do. Simple enough. Read the parameter, display it. Right? So then we'll go to the next one, which, oh, look, I put in script alert 1. My code just executed that unexpectedly. If I do the inspect, what you'll see is that the response body changed from a text response body to HTML. It's built into most of the browsers. If it detects a tag being responded back, it's going to switch it to HTML, which then triggered the execution of that script in my parameter where I expected the name. Kind of weird. Now in Go, you can make it so that that doesn't happen, but we're going to, let's see if this is, I have 4 windows and I'm not, so again, I'm going to get an alert 1. So the first 2 tabs have the same engine running on them, where they're not doing any validation. Then I tried on the 3rd one to do some validation, but I still got it wrong. So then if we go to this third one here, again, same script, same parameters. It actually responds as I expected, just taking that and making it a piece of text to be displayed instead of executing. And we'll go over that code now, what that looks like. And this is where cross-site scripting is super easy to do, and allows for, it's been 6 years. It's that specific vulnerability has been in the top 10 for 6 years. So we're going to share my code here. This code, and it's super simple, and then we'll move on here. Got all these extra. Let's see if I can move them out. So they're all currently running, but here's my first initial server where I just literally get the parameter. A template. I get the parameter, and I then string it back out. Super simple. I've seen lots of code that does this. It just says, give me the parameter, right? So in the database, you're good to go. Then you see that parameter and convert it into a parameterized database, and you're like, looks great. The next time you load the page, it's not so great. So then the next step is I said, let's make it a template. Because that should escape it, and you all should do. The key thing to note here is that it is, I've got it defined as a text template. So it's going to try to return it as text, which then doesn't escape the characters correctly because it doesn't recognize the HTML tags, which was the third tab that I showed you. So the final solution here is to parameterize and recognize that it's an HTML template, and it will then write it out correctly. So as you're taking inputs from your users and validating them, make sure you know what you're validating and why you're validating it. There are cases where you might want to accept scripts into your interfaces. For the most part, if you put a script in a field that you're expecting text, strip all the tags. Doesn't matter, because if they're messing around with you, your name's going to look funny, but you will be safe and not risk exposing yourself or your customers to cross-site scripting. And these are all running as right now as little Go routines as there's. Oh, I didn't quite write the code all correctly on that one, but anyways, let me come over here. Stop sharing the code, come back to the slideshow.
Essentially what you're saying is the text template is just a really fancy way to print again.
Yes.
Instead of printing text, but you're relying on HTML template to do some native escaping of template variables.
Correct.
Okay.
Correct. And so, if you're doing the HTML template and you save that to the database and bring it back out, it's not going to execute it coming back out. And so there's many other variations. I only have a certain amount of time, so I'm giving you some quick examples of that. Like I said, I'm going to run into the slides later on. So let's talk about Docker. Where do I start on this? If you're currently using Docker, let's have a show of hands. How many of you guys have your own Docker registry, or who relies on Docker Hub? Let's go with first. Who has their own container registry? 2, 3, 4, 5. How many of you guys currently rely on images in Docker Hub to store your images? You do both? Okay.
Are they copies of each other?
I was really good at this at Domo. We would, even if we're going to use upstream images, would always pull them privately
Down.
and because then they couldn't swap out from underneath.
Yeah, so that's what you want to do.
Right, but I'm not doing that right now. But I should be, but I'm not.
If you're going to use a Docker image that someone else built, fantastic. There was one that was, I think, in the top 5 used container images from Docker Hub. The account got compromised. They put a Bitcoin miner in there, and away it goes, literally onto millions and millions of machines. That container was deployed. as they refreshed.
It's a bit safer if you do hashes, because then at least you know the
Yes.
hash hasn't changed,
Yes, it is.
but nobody does hashes.
No one does hashes. So your safest bet is to know what you are actually pulling into that image, copy that image locally, and maintain that image on your own. What that means, though, is that you're going to have to be periodically checking back out to see if they've done anything to that image to cover a CVE or something like that. And so, hold on, I got to go back to my slide deck here because I'm missing like 5 or 6 slides that I was expecting. Did I move them? Oh, yeah, that's fantastic. Okay, we'll get there. So one of the major pieces that came out is still a significant problem is access control with Docker. A lot of times Docker will run as the default, which allows for a lot of fun execution that you would not expect.
But also, taking a moment to say, do immutable images if you can.
Yep.
We're talking about images, like, even if your own internal thing, like, it protects you from accidents and rogue agents.
Yes.
To say, like, version 1 will always be version 1, never push over the top of that again.
Yep.
Nobody can.
The making it so that it has to go through GitOps and build process and check your code, all of those things apply to your images. At a company that I previously worked at, I had to demonstrate to them for their, we'll say, their phone build process. I was able to, in the middle of their build process, inject a coin miner just prior to them publishing it out to Apple, compromising both the build and potentially what what would have hit the Apple Store. So, with containers, there's so many attack vectors. There's your application, your orchestration, as well as potentially your neighbors who then are able to compromise you by gaining access to the host, get to the PIDs, and you can see what you're doing as well. So this is currently we do DevOps already, just without Agile, stand-up CI code, or any of the other hipster stuff. Yes,
What exactly is orchestration?
a very bad misspelling.
Okay,
Orchestration.
all right.
Thank you.
Did you not? You actually need orchestration? Like, if it wasn't typo, would you know what I meant? Because not everyone may understand what orchestration is. I'm throwing that out there. You may want to cover that.
It's hipster stuff to make it complicated.
That's right, it's hipster stuff. So orchestration is,
I don't know.
Kubernetes is sometimes considered an orchestration. You have Puppet, Chef. It's how you get your code deployed. It's the process you use to get your code deployed. And those systems can be compromised via your containers as well.
So orchestration just used to be the ops guys.
It used to be
the orchestration.
Yeah, it just used to be your ops guys, but now the tooling where developers can control their own destinies a lot more with the containers, but there's caveats that you have to know and understand there. So let's talk about the containers. In DEFCON and Blackhat, it was considered the largest threat and attack vectors. There were numerous talks on containers, what they've been used to compromise, and how they could be compromised. Let's see. Oh. So in a Sky Talk, if you've been to DEFCON, the Sky Talks are not recorded. They will literally take your phone and smash it if they see it. It's because what they're demonstrating in those Sky Talks is still active and live as of the conference. This year they showed how to compromise the using Google Cloud Build. They got to a Google host box via a Docker exploit, along with Docker and Docker code execution. And so the one thing that I learned out of that is if you can avoid it at all costs, do not do Docker and Docker. It opens you up to a lot more exploits that currently are still being uncovered. Yes.
Why would you do that? Why do people do Docker in Docker?
Builds a lot.
Okay, so you're talking just for a build. You're not talking running in prod or something.
You're talking about you want to like build, you want to have a known build environment, so you build a container, and then you want
Right.
and it's always been kind of a hard. There are many ways to do it now. Like there are systems that don't need Docker to build Docker images.
Okay.
It's mostly the builds, but you'd be surprised that there are, like, they want to get rid of VMs completely, and so like, oh, here's a Docker container and it's running all these other Docker containers.
Yeah, I guess.
So there's
I
scenarios.
see it in builds a lot.
Yeah, it's mostly in the builds, but with those builds, then it allows vectors of escape and access to your local mailbox that then you end up with like all kinds of things. So in the Google instance, they ended up being able to see like a half a dozen companies worth of builds going on. So if you have keys and API keys and those things, they are literally sitting on that box, waiting for someone to come by and pick them up, right? And so that's where the Docker and Docker don't do that, if at all avoidable. If you have to do it, lock it down, add some compensating controls, make it so that you're not exfilling data from that channel. Make it, like, why should your Docker be sending something out, potentially at the end you have an artifact that you send out, but during the build process, nothing should be going out and grabbing random URLs. And so very, very super interesting. So containers, a part of, who here doesn't use containers? Is there anyone? You don't use containers at all?
No.
No containers.
We're a healthcare company,
Oh, yes.
and the cybersecurity department is still in the vetting process for containers and everything for compliance with HIPAA.
Yep. Yes, that gets a lot more complex to do that in both PCI and HIPAA environments.
Last year, we started using VMs.
Oh, boy.
That's when we got.
You have a little ways to go.
So, yeah.
That's right. That's the healthcare.gov. Built, I think, when was it, like 2015 or something? It was built on Windows 2003 because that was the only thing the DoD had approved at that time. So your story, our government faces that as well. Let's talk some Kubernetes.
Kubernetes is secure?
By default, yeah.
By default,
Yes.
it is
No, it's not.
insecure. So the Kubernetes core team was at DEFCON giving a presentation. Their number one presentation was the 22 ways to compromise Kubernetes. 22 ways that they could demonstrate live to compromise Kubernetes. They built Kubernetes as a runtime environment based upon what Google had done with almost no view of or perspective of security. And now they're trying, they literally have postings out, security people come help us please all the time, because they didn't expect Kubernetes to catch fire like it has. And with Borg and what Google runs, they have a lot of other security controls around it. The companies that are using Kubernetes right now are not having those same controls. And so the first rule of Kubernetes Club is we don't talk about Kubernetes. No, it's one of those pieces that it's really easy to get up and running. It's great for developers. It currently has a lot of significant security implications that unless you're ready for it, unless you're ready to put some additional pieces in there, be aware of it. Now I want to talk about a completely terrifying SkyTalk. After having watched them demonstrate how they could compromise Kubernetes, I went to another SkyTalk where the individuals scanned 87 million addresses from Azure to Google to AWS to DigitalOcean. He had accidentally reformatted his machine, wiped his data, and so he was doing it live on stage. And he had scanned for Kubernetes admin ports, 10.250. That should be 255, I believe. So across DigitalOcean, he's found 4,000 instances of unauthenticated read access to Kubernetes clusters, and he found 6,000 instances of the admin port being open. So as he's demonstrating this live on stage, he then asks these admin ports for their pods and for their containers. And myself and 4 of the other Weave engineers watch as the name Weave rolled on the screen, it doesn't.
We don't use DigitalOcean.
And we're all like,
Oh, the other weave.
no, it wasn't the other Weave. But for about 20 minutes, we're all like, please. I'm like running through my head. I literally don't have any assets on DigitalOcean that I'm aware of. That's the caveat that I'm aware of. Our teams are pretty autonomous and can do what they need to do. I'm literally slacking one of our IT guys going, can you go verify that we don't have anything out there?
I thought you said you couldn't have your phone though.
So I had my phone because I have my phone. I'm using a Pixel that's encrypted and that I only allowed for the encryption connection that was also encrypted. So I felt for the first year, actually, it's the first year that I didn't just have a burner phone. I took my main phone to see how well it did or did not do.
They didn't smash it? It's a SkyTop.
So I didn't record it. We were just sitting there watching it, being terrified that we may have just publicly had our information and pods disclosed and this port open for admin. So about 20 minutes after the thing, we got to finally meet with the guy and said, we think we saw our name. And he apologized. He's like, I apologize. I had prepared this, but I lost it. So I was just running the commands. And he's like, what's your name? He slides me a paper and we write down the name. And he does a grep and he's like, oh, right here, there's 12. And I was like, what do you mean there's 12? So, like, wait a minute. So then he shows me what they are. There's a open source project out there called Weave-Net. It was all networking mesh. Thank goodness. It was all networking mesh. But for about 20 to 30 minutes, I was going, oh my gosh, this person has access to our admin port. And just demonstrated it for everybody. So,
Well, the thing about that is, for the longest time, like all the initial offerings for the public clouds for Kubernetes managed services were just public everything.
Yep.
Every single node got a public IP address by default, and that was like their first offering, every single one of them. And
GKE still, if you spin it up, the ports are,
yeah,
the admin ports are there.
and it wasn't until much later after they started doing those public offerings that Kubernetes came in and made it really, really easy to generate one-to-one certificates for every single node so that the Kubernetes API individually auths to every single node with a unique certificate. And that timing was really bad because we had all these offerings that were just public everything. Then they added security, and then you just got, it's way too easy to just open.
You have thousands of clusters that are running into a state where they don't have that auth.
Yeah, they're all told.
You can literally go and drop their container if you chose to, and you know their IP and port. So these are things that Kubernetes, fantastic, works well with the Go process and containers, and it makes it super easy to deploy. This thing that I have up here is Pirates. It was demonstrated. It's an open source project that helps scan your Kubernetes cluster to look for any known vulnerabilities or CVEs. Very useful tool. Clicking the next button. Oh, so the variation of this tweet was used all throughout the conference to compromise most Docker themes as well as Kubernetes by the dozens. But essentially it allows you to run in privilege mode and gives you then a redirected standard in bash to the root, to the box. So yeah, that's a fun one. Don't run that command. But
Does it have to be specifically in overrides, or is it if you wrote it to a YAML and brought it in?
it doesn't have to be in the overrides.
Okay, that's just their way to put it in line on the command.
Yeah, that was just this individual's ways to put it in there. And so this technique is what they use to compromise Google. To go right through their security. If you're using containers and Kubernetes, there's a thing called an admission controller. Use that.
Well, even above that, pod security policy has been in Kubernetes since like the last year.
Yeah.
And you could just say flat out across namespaces, you can't even get privilege in this namespace. So
Right.
There's
a couple methods to deal with it.
yeah.
Yeah, the admission controller will allow you to, and again, this isn't specific to coding, but most engineers that are doing coding nowadays, especially in Go, the combination of containers and Kubernetes is super prevalent. It is not guaranteed, but it's about an 80% ratio out in the industry that you'll be using one of these tools. So that's why I'm covering it, because It's not just the code you're writing, it's the ecosystem you're living in. So some resources. I have no idea how much time. How?
You've got 15 minutes.
Okay, I'll wrap it up here in
You've
15
got
minutes.
time.
So CVEs, if you don't know what those are, it's, I just lost its name. It's, there it is. It's like critical vulnerabilities. Exploits, that's the word I was looking for. I have this streaming to my email every day. This one's Golang. They've had relatively few CVEs. Compared to Docker and a few others, Go has been very calm on the CVE front. But if you're looking to step up your game for security through containers and Kubernetes, start subscribing to CVEs. They're amazing and slightly terrifying sometimes. NVE database is another one. Now this one made me laugh when I saw it, so this is on their public site right now. This is a vulnerability that was found in Jenkins Splunk plugin, a security software. So that's slightly funny. Splunk's used in a lot of organizations to detect security breaches, and their own plugin has a vulnerability. It's ranked high. High is bad. Yeah. There's another project called Forseti Security. This helps you keep track of everything that's in your GCP. Works with Kubernetes. It allows you to enforce rules and policies as to what people can do. If you work in a HIPAA or PCI environment, this kind of tool becomes essential to keep a catalog of what all your random teams are doing all the time that you don't control. As an engineer, keeping an eye on the OWASP top 10 is important that you understand portions of that. I don't think you have to understand every portion of it because there's still things on that top 10 due to people using physical boxes. The last 3 or 4 are mostly in your ops and security environments, not necessarily related to code. But those are converging. They're converging rapidly. So, and then Kali Linux, it's an amazing tool for hacking just about anything. So then I'm going to do 2 slides on my soapbox. Having been an engineer my entire life, moving into security, every piece of security is about data. What you can do with that API token, what someone else can do with that API token. Knowing the data that you have, being educated on the data that you are processing will help you and your entire company. I have a lot of empathy towards engineers, and my goal is to educate security people as well as engineers to be empathetic towards each other. Like, security has a tough job. There's literally millions of CVEs, different attack vectors, and they, as much as they want to not provide unnecessary steps, you then also have to deal with your compliance teams, which, well, that's a whole nother story, but compliance also drives a lot of those pieces that, in my perspective, compliance oftentimes adds those extra hops that you have to go through, that if you're looking at it from purely security standpoint, you wouldn't necessarily do. Am I going to lock my door? Yes. Am I going to have 3 front doors? No, I would not. So, but I think security, focusing data, focusing on how you use that data, what that data will be used for, and then shifting security left. What that means, this would be my ideal world right here, where we have devs and dev and ops, but security pops in here right at the very start in the gathering of some of the requirements, so that the team that is designing whatever it is, they know what the requirements are up front that they have to meet. Eventually, we'll be there. I think more and more of the industry is talking about this. Because when it's a bolt-on after the end, that's when you have problems. So, that's it. Do you guys have any questions, comments? Did I see a hand back here? Yes. So here.
your average Go web developer, what are the top three things you should go to your code base and go do?
Top three things. Sure. So literally all the top three things could fall into the validation portion of it. Make sure that you're accepting the parameters, that you're escaping them. So if you're just on the web server portion, those are the primary pieces of managing that you have to look at the back end and say, what can I hold? One of the great ones that was at DEFCON as well is the ability to trick web servers by having content lengths from your front end to your back end be off by 1, and they could then inject a new command that the person compromised PayPal and retrieve passwords. So understanding what's in your back end and what the sizes are, and making sure you're doing all your validations. On the front end is the primary focus there to prevent Crosssite as well as data infection into other areas.
Buzzing is really good with that too.
What's that?
Add a buzzer, like you'll never know what will make you crash.
That's
Buzzers
true.
will catch a lot of that stuff.
Buzzers, right now we're also adding some security scanners to Weave to look for any open source projects that have CVEs in them so that we can be alerted.
Didn't GitHub just start doing that on other languages? They haven't done Go yet.
They haven't done Go yet, but there are some companies out there that currently do Go. But those are pretty common things that someone else has a vulnerability, you just don't want to have that also be your problem. So patch it. But it means that you have to keep up on it. Any other questions, comments?
I had a question about the Docker and security, which we were talking about.
Yeah.
We use multi-stage Docker builds, a single Docker file. Is that what you were talking about?
No, that's different. So in a lot of build systems, Jenkins, GitLab, they use Docker as the environment for you to build your Docker artifact. So that is where you get the Docker inception. And that it doesn't end there. You can actually go like 3 layers deep. It gets really crazy as to what you can do. But what you should do is not that.
They talk about like layering, like could you do a Docker inside a run C, or like can you at least make it that if they break out of one, it's a different layer that they have to try to break out of? Or
so layering is slightly different than Docker and Docker. Layering is okay. The fewer the layers, the better the layers that you do have. You need to know what you have in them. For Weave, we actually have a pretty good story there. All of our Go containers are run from scratch. If you can get from scratch, there's no shell, there's nothing. There is nothing they can do. It eliminates your entire application attack surface by doing from scratch.
If you aren't in Go and you statically compiled, there's distro lists, variations. It's literally called distro lists. It's some Google provides for most of the major languages, where it's like just enough to run a certain language and no side utilities.
but aren't they still just using like the PID namespace? Like you don't need any executables if you can.
Right, but you have to have, but if you don't have any tools to manipulate the namespace, like everything's like write a file here, but if there's no way to write a file there, then read-only root file systems also can go a really long way in extra security. You have to really understand your code and understand all the 10 places it's going to drop things, but you can't change code, anything possible.
Sarah, let's do one more question.
One more question.
Unless nobody has any questions.
One more questions, stop me afterwards.
Yes.